Hello friends, good afternoon and welcome to the EduSat network. Friends, our topic of discussion today will be part of our ongoing series on operations management, and today we shall talk about just-in-time single minute exchange of data, which we have already mentioned as JIT, SMED. And friends, for this very discussion, we have with us our expert Dr. Subhash Kakkar. He is director of a very well-known institute in Delhi and has been closely associated with us for quite some time. And friends, with this very brief introduction, I welcome sir to the studio and also request him to begin our today's lecture. Sir, thank you for coming.
Thank you. Welcome viewers. Today's lecture is part of our series of lectures on operations management. Under operations management, we started with the topic JIT, lean manufacturing or lean operations. Today we shall be discussing SMED. Soon I am going to tell you the meaning of SMED. For any process, if we want to analyze that process thoroughly, we must map the process so that we know exactly the activities which are involved in that process, and that process is part of a job. Any modification, any improvement, if it is required in that process, we must map the process. On a piece of paper, the mapping of the process is done. And looking at the process map, we can see what all activities are involved in that process and where exactly we can introduce any modification, and what are the activities which are surplus or what are the activities which are consuming more time than the specified time, or the process can be improved. Some of the non-value added activities can be removed. Non-value added activities are the delays, and these delays should be avoided in any process. If we do all this, then the time taken to complete the process will get reduced. That is our aim today. Soon you will know what is the full form of SMED and what is the meaning of our lecture today. What topics are going to be discussed? I said map the process. When we are mapping the process, a number of symbols are used and maybe we will require the help of time and motion study. And videos are also to be prepared for analyzing any process. Micro motion cameras are used for mapping the process, and videos are seen again and again so that we can come to the conclusion that where exactly improvement is required and improvement is possible. So, today we shall be devoting time on studying what is meant by SMED and why it is so important as a part of JIT. So far, I am not able to disclose what is SMED. I am just concentrating on any process which is mapped and modified so that the time consumed for completing the process is minimized. Sometimes a process which used to take days is converted into only minutes, and the time taken earlier, if it was in minutes, now it can be completed in seconds. And because of logical reasoning, looking at the process mapping through time and motion study, we introduce modifications in the process. Now, why this SMED and why it is important in JIT? We have discussed a different and a number of success factors which are responsible for making JIT a great success. And the setup time is an important point, important success factor which we have discussed earlier. Now, we will discuss setup time in detail, and SMED again is nothing but reducing the setup time. Full form of SMED is single minute exchange of die. SMED, single minute exchange of die. a factory is running or a process is running to produce a certain product, and now we want to change the setup to a different product, and the time gap in between changeover is the changeover time or the setup time, and we want to minimize this setup time. What are the rules, what are the principles which should be implemented so that we are able to reduce the setup time to its minimum level? Today we are going to discuss all those principles, all those rules, and that will become the part of SMED, single minute exchange of die, to get to a new product from the existing product. Quick changeovers. Changeover is nothing but setting the machine to a new level of production. Maybe we have changed the capacity, maybe we have changed the product. Say for example, in the software industry, rather we should discuss the soft drink industry. If we are manufacturing one product, say 500 ml bottles, and we want to change them to 2-liter bottles, the time required to set up the machine from 500 ml to 2-liter bottle is the changeover time or the setup time, and this is in connection to single minute exchange of die. So, we are to discuss today how to reduce the changeover times and how to reduce the setup times. What is a changeover? The changeover time is the amount of time taken to change a piece of equipment from producing the last good piece of a production lot to the first good piece of the next production lot. This statement covers the definition of changeover and the changeover time. Here we are discussing two products. One is the existing product and the other is a future product. We are manufacturing existing product and we want to stop the production of existing product and we have to start the production of new product. The last product, when we stop manufacturing, we will start counting the time from that particular point till we get the new product, next product of good quality, and this is called the changeover time, this is called the setup time. SMED, single minute exchange of dies. S is taken from single, M is taken from minute, E is taken from exchange, and D is taken from dies. So, single minute exchange of die is the topic today we are going to discuss under GIT. I will give you an overview of what we are going to discuss in today's lecture: what, why, where, how and who. In this lecture, we will discuss the following questions and learn how to use SMED for continuous improvement. What is SMED? Why is it so important? Where should it be used? And how do we use it? How do we sustain it? And who is responsible for carrying out it? Where do we go from here? So, we will have answer to all these questions today. When is the changeover complete? Running product A, downtime, muda or waste. What is this downtime? This is the time required for setting the machine to a new product and running the new product. We are having two products, product A which we are running at present and product B which we want to run it in future. We will stop the production of product A, we will make the changeover and we will start the production of product B. In between time is a changeover time, that is a down time in which no production is carried out. Why quick changeovers? Quick changeovers reduce the lead time. Lead time is the time required to give a new product to the market or to the customer and increase overall velocity. If we reduce the changeover time, overall velocity will improve. Machines only create value when they are running and not sitting idle. So, we want the machine should be running all the time without sitting idle, because the running machine will give us the output. Running machine will give us a manufactured product, not the stopped machine, not the idle machine. So, we want the machine should be running at all the times. So, the changeover time, the setup time should be minimum, because in this period the machine is idle, machine is not producing anything. Reduce lot sizes. If we reduce the lot sizes, for that we require the changeover time or the setup time to a minimum level. When lot sizes are reduced, the customer's lead time is also reduced. Lot sizes we have already discussed, because the lot size, if it is less, it is small, then we will have less of inventory level maintained in the factory. Less of WIP will also be there. Work in process inventory will get reduced. This is because most of the lead time is waiting time, queue time. So, we must attack the setup time, we must attack the changeover time. Quick changeovers reduce inventory. Fast changeovers greatly reduce the need for inventory buffers. Removing the non-value added time results in the customer getting their product sooner. If the machine is not sitting idle, it is producing without being idle, then the customers will get the product very fast. Now, we will discuss 8 techniques to quick changeovers. Now, we must discuss this thing also, because we want to minimize the time required for changeover, time required for setup, and there are 8 techniques which are used for reducing this time. The first one, the separate internal from external setup operations. There are internal operations, there are external operations. Internal operations should be separated from external operations. Soon we will discuss what do we mean by internal operations and external operations also. Convert internal to external setup. Let me explain the difference between external operations and internal operations. Internal operations are those operations which are done on the machine when it is running, external which are done while the machine is not running. So, this is the difference between an internal operation and external operation. Standardize function, not shape, and use functional clamps or eliminate fasteners altogether. So, use only clamps instead of fasteners for quick operations. Use intermediate jigs also, and adopt parallel operation, do something parallelly so that your time is reduced, not in sequence. And eliminate adjustments, no adjustments be required during the setup time, and mechanization should be preferred over manual work. This will reduce the time. These are the 8 techniques for quick changeover. What is SMED? Single minute exchange of dies, developed by Shingo. He was a Japanese consultant who gave the idea of SMED, single minute exchange of dies, a system designed to radically reduce the amount of time to perform a changeover or setup. SMED is a system which is designed to radically reduce the amount of time to perform the changeover or setup on any machine, and this idea was given by Shingo. Shingo's success, a revolution is manufacturing the SMED system. SMED system is a revolution, and Toyota using his techniques reduced setup time from days to 3 minutes. Toyota company used the Shingo success technique, which is SMED, and the setup time was drastically reduced. Earlier they used to do it in days and they started doing it in minutes only. So, this was the success of Toyota also using SMED technique. Focus on the process, not on the technology. He says that you have to focus only on the process, not the technology required, and that will give you reduced setup time. SMED should be inexpensive. We should not have any expensive ideas implemented under SMED. Only small good and effective ideas where efficiency is improved should be implemented. Well planned, and again everything should be well planned under SMED. If everything is well planned, there is no scope for any increase of setup time. Everything will get reduced. Well practiced, you do the practice again and again, so that you are doing it faster every time. And well executed, SMED operation should be well executed. Okay? No confusion, no ambiguity. Without standard work, there is no continuous improvement. So, everything is to be standardized, everything is to be made like standard operating procedure when we are doing the changeover, and everything should be moved in a planned way, in a standard work procedure way, and then everything should be recorded also to get the minimum time during changeovers. Shingo's success. Changing dies on stamping machines took up to 3 days to complete. Placed precision measuring devices on the die used instead of eyeballing. And tools designated for SMED were located close by, and no time was lost in locating the tools which are required during the changeovers. Cut the changeover time to less than 10 minutes. And now we will discuss 7 steps to implementing SMED. The first one is observe the current methodology. The current method being used be thoroughly studied. I said process be mapped. We can make use of time and motion study. We can make use of micro cameras for recording, for making videos, so that we can study each and every component of the process, each and every component of the activity, and we can suggest the modification required in the process. So, the first one is observe the current methodology. Watch a full changeover process at least once, and more is better. See the changeover process, existing changeover process again and again, so that you get conversant with the changeover. And if you are conversant with the changeover, you will be able to suggest modifications required in the process. And videotape is best. Make a video of the changeover process so that you can see it again and again. Second step, separate the internal and external activities. Internal activities are those that can only be performed when the process is stopped, while external activities can be done while the last batch is being produced or once the next batch has been stopped. For example, go and get the required tool for the job before the machine stops. The second step, I will repeat it. The second step, separate the internal and external activities. Internal activities are those that can only be performed when the process is stopped, while external activities can be done while the last batch is being produced or once the next batch has started. For example, go and get the required tools for the job before the machine stops. So, this defines the internal and external activities. Third step is convert, where possible, internal activities into external ones, so that you will not have to wait for stoppage of the machine. because those activities are to be done externally and these are independent of the running machine. Like preheating of tools is a good example of this. If any tool is to be preheated, it may not require the stoppage of the machine, it can be done separately even if the machine is running. Fourth step, streamline the remaining internal activities by simplifying them. Now, here we are suggesting you simplify the identified internal activities, focus on fixings. Shingo rightly observed that it is only the last turn of a bolt that tightens it, the rest is just movement. When we are tightening the bolt, we give 5-6 rounds before it gets tightened. These 5-6 rounds do not have any meaning till we tightened it in the last round. So, last round is the round which tightens the bolt. Only the final turn on a bolt adds value. The value in turning is only in the last round because that is the round which tightens the bolt. The interrupted screw or interrupted thread provides one means of clamping and unclamping something quickly. Artillery breeches have been sealed in this manner since the 19th century. This is an example of bolt mechanism. Fifth step, streamline the external activities also. When we have streamlined the internal activities, now we will concentrate the external activities and we will also streamline them so that they are of a similar scale to the internal ones. Both internal activities and external activities are streamlined. Now is the turn of document the new procedure and the actions that are yet to be completed. We are to record the new procedure which we have devised, which we are going to use, and this documentation should be part of standard operating procedure. Once it is recorded, it will record the everything what we want to use. Seventh, the last step, do it all again. For each iteration of the above process, a 45% improvement in setup times should be expected. So, it may take several iterations to cross the 10-minute line. In this step, we are saying that whatever procedure we have made so far, that should be tried a number of times. Each time we want to reduce the time and close to 40% reduction in setup time, and keep on doing till it is stabilized to the minimum level, and that is the time we are going to assign to the setup, which we are going to assign to the changeover. Look for opportunities to eliminate wastage your changeovers, then go after them. Each time when you are repeating, you have to record any opportunity for reducing the time, and that opportunity should be made use of, and that opportunity should be implemented so that there is a reduction in time. You may make video for that also. You may record the activities if you want to make any suggestion for improvement. If video recording is there, micro motion cameras are used, activities to the micro level are recorded and suggestions are made for them. Look for what? Shortages, mistakes, inadequate placement of needed equipment can be avoided by using check tables, especially visual ones, and set up on an intermediary jig. Here, shortages be recorded, shortcomings be recorded in the process, what we have found. Maybe shortcomings are in the form of shortages, and maybe in the form of mistakes, and maybe in the form of inadequate placement and alignment of equipment, and that should be recorded clearly. When we are able to record the shortcomings, we are able to record the shortages, we are able to record the mistakes. When all these recordings are with us, one by one we will find solution to each one of them, and they are going to reduce the setup time, they are going to change over time. And these can be recorded on a piece of paper in the form of tables. And on the remarks column, we should write the solution to be implemented for removing or getting rid of the mistakes what we have observed. Inadequate or incomplete repairs to equipment, those should also be looked for and recorded so that we get rid of all these incomplete, inadequate repairs. Optimization for at least work as opposed to least delay. And then finally, we have to optimize for least work as opposed to least delay. Look for unheated molds which require several wasted tests before they will be at the temperature to work. During setup procedure, we require molds to be heated to a certain level. At that level should be recorded to what temperature we are supposed to heat the molds. Exact that temperature should be maintained before stopping the machine for setups, because it so happens they are not sufficiently heated and we start using them, and in the process we find that this low temperature is not going to run, then again we have to remove the molds from the machine and heat them again. So, once we know that to what temperature we have to heat the molds, exact that temperature should be maintained, and then the machine should be stopped for changeovers. And that should be the idea behind the internal activities and external activities. Equipment using slow, precise adjustments for the large course part of the adjustment. Minute adjustment should be carried out so that we are able to make the large adjustments possible. Lack of visual lines or benchmarks for part placement on the equipment. We should look for these things. There should be visual marks for making alignments, for fixing items or joining two parts during the setup, during the changeover. It is like an assembly work, and assembly work should be done in a scientific way. Part placement should be accurate and the fastening should be quick. That is the idea behind any changeover, and we have to look for these suggestions and look for these modifications which are possible in our existing method. Now, forcing a changeover between different raw materials when a continuous feed or near equipment is possible. Lack of functional standardization, that is standardization of only the parts necessary for setup, that is all bolts use same size spanner, die grip points are in the same place on all dies. These are small things, and these are vital operations, and they reduce the time drastically. We should have standardized fasteners during the changeover to be used, because if we have non-standard fasteners and different types of fasteners used during the setup, we may have to have different sizes of spanners ready to be used. So, these kind of problems can be avoided if we use only standard fasteners and of the same size, so that one spanner will be used for tightening or loosening of the bolts or the fasteners. And similarly, that should also be the criteria for dies, etc. And look for much operator movement around the equipment during setup. we have to look for the area where more operator movement is there in the existing method. We have to pick up those points and we have to reduce the operator movement. If we are able to reduce the operator movement, then changeover time will get reduced, setup time will get reduced, and our SMED will be very effective. More attachment points than actually required for the forces to be constrained. We look for more attachment points so that modifications are possible. Attachment points that take more than one turn to fasten. We said it is the last round or the last turn of the bolt which fastens the parts. So, we should have attachments where only one round is possible and the things are attached and things are fastened, and look for any adjustments after initial setup and any use of experts during setup. Any adjustments of assisting tools such as guides or switches, all this should be looked for so that we can have a solution to these problems. Say for example, any use of expert during setup, if it is required, then expert should be available at site at that particular point, or his expertise should be learned by the operator himself so that he can himself do all the expert jobs during setup and during changeover. If any changes are required after initial setup, that should also be looked for. Improvements with successive runs. We look for successive runs. Any modifications seen should be recorded and that should be implemented also. The idea behind doing it again and again is that when the operator does it again and again, then he gets conversant with the process of changeover and the process of setup. He himself will suggest some methods so that the changeover time can be reduced and changeover time can be drastically reduced. It can take, earlier it used to take say days, then it can be done in minutes also. And this is the idea behind doing it again and again, and in successive runs more suggestions are recorded. And this diagram shows that how doing it again and again the time of changeover is getting reduced. We are discussing setup time and the possible reduction is there or not, yes or no, and then finally we shall be able to reduce it. And this gives us again in the diagram how the time can be reduced, where is the scope for reduction, it is marked on this drawing, and all the activities there and the time taken by those activities is required. And these movements are also shown from A, B, C and D, and where exactly the changeover setup time reduction is possible and that is introduced. Here external activities are recorded, internal activities are recorded, how the external and internal activities are streamlined, and this is being clarified in this diagram also. Parallel operations using multiple operators. Here the suggestion is that do lot of jobs parallelly and simultaneously. Instead of doing the jobs in a sequence one after the other, try to make the jobs in such a way that they can be handled parallelly. 2 or 3 jobs being done at one point of time so that the total time required for completing the changeover is reduced. Level load the changeover and balance the task. This is the main principle of the changeover, because balance the task at every, say we have decided to do it simultaneously, and simultaneously at 2-3 locations the jobs will be carried out, and at 2-3 locations the job should be divided in such a way that they are balanced, means idle time on each point is 0, is negligible, only then we shall be able to reduce the total setup time. This again diagram shows the teamwork parallel operations using multiple operators. Multiple operators are used for carrying out different jobs simultaneously, so that the total time for setup and total time for changeover is reduced. And SMED tool carts, these kind of tool carts be used in the factory, and these tool carts, let us spend some time on the design of the tool cart. For each changeover, a separate tool cart can be designed, or a common tool cart can be designed. This is a tool storage area which includes and displays number of tools which are required during the changeover, and these tools are displayed on a board where we can see that this is the particular tool to be used, and the area where it is going to be kept on the tool cart, and a boundary or the outline is also marked on the tool cart. If the tool is removed from the tool cart, its boundary marked will show us that this particular tool has been removed. Its outline will show us that the particular tool is missing from the tool cart. So, one should look for the tool where it has gone, and the tool cart should be completed before starting the setup, and that tool cart can be moved closer to the setup area where the machine is going to be set up, where the changeover is going to be implemented. This tool cart should be placed there, and the mechanics can start working, and they cannot they will not waste their time in looking for the tools, because the tools are available on the tool cart, which is put close to their operations. So, this is a particular design of a tool cart. Sometimes we place the tools in front of the machine itself, and these can be kept hanging on the wall in front of the machine itself. The people or the mechanics can take the tools from the board which is kept on the wall in front of the machine, and the tools can be removed from them. And then suggestion is that tools are kept on the board and their outline is marked on the board. Whenever a tool is removed from the board, its outline will show that this particular tool has been removed from the board, and we should look for where it is before starting the changeover without starting any new setup. This will reduce the time, because we waste lot of time in looking for the tools. If the tools are available close to the operation area, then practically no time is wasted in locating the tools. So, this is a good idea to have a tool cart or a tool board for changeovers. SMED, single minute exchange of die. SMED, changeover reduction, is a tool supporting lean manufacturing. It is used to control and decrease downtime due to changeovers. This particular SMED is part of only lean manufacturing, lean operations, or just in time. SMED supports concept of continuous improvement through removal of waste, and this waste is wasteful activities, and these will be visible only if we map the existing process and see it, analyze it thoroughly, and suggest the modifications for reducing the time. SMED will make the job more structured, repeatable, and easier. Three things are being talked about here. Structured means streamlined. The process will be structured and streamlined so that it is repeatable. When these two things are there, then the process becomes easier to implement also. SMED will take care of our customers better than we do today, because the lead time is reduced. The customers will get the product faster, because we have implemented SMED where the setup time is drastically reduced. The customers are going to get the material very fast. SMED is about increasing productivity by decreasing the time from the last good product to the first good product. Here in the middle, we are showing the setup time, On the left hand side, last item type process means last product, say product A is the existing product being manufactured on the machine. So, last product manufactured on the machine and it is stopped for changeover. Now, the setup time starts and in the last first different item processed, and that is the time of setup, means stoppage of product A, making a changeover and production of a new product. The time between the two activities is the setup time or changeover time. Why is SMED important? Reducing setup time helps us to better serve our customers' needs and decreases lead time. Smaller batch sizes are used and increases flexibility. It gives us a flexibility. It becomes more flexible system because changeover time is minimized. At any time we can make a changeover, we are flexible and we can satisfy the customer with his needs, with his requirements, because changeover time and the setup time is reduced drastically and we have become more flexible. Increases customer on time delivery. We are able to give on time deliveries to the customer, get product when they want it, because our setup time is reduced. Without wasting our time, we can change over to the customer needs. Supports talk time. What is talk time? It is the time a product takes to meet a demand cycle time, and this is called the talk time. We are able to reduce the talk time also, and we are able to satisfy the customers to their fullest extent. Run to customer demand, not standard, and allows us to keep all customers happy. Each customer gets what they want because they have different requirements. Earlier we used to take lot of time in setting the machine to the customer requirements. Now, using SMED concept, we are able to reduce the setup time, changeover time to its minimum level. We can satisfy the customer without wasting time. Why is SMED important? It is better able to provide all customers with what they want quicker and decrease inventory. Let us see this process which is going on. Customer has given a requirement of 4 A's, 4 B's and 4 C's, and schedule is 4 C's, 4 B's and 4 A's. Immediately, if the setup time is minimum, it can be changed over to the customer requirement and we can satisfy the customer to his fullest extent. Now, look at the future. Again the customer requirement is changed, the schedule is different. Customer requirement is A, B, C, A, B, C, A, B, C, A, B, C, and the customer is schedule is C, B, A, C, B, A, C, B, A, C, B, A, and it can be changed over to the customer requirement without spending more time. Again the sequence will remain 1, 2, 3, 4, 1, 2, 3, 4 and the customer will satisfy it. Why is SMD important? Think, how would you handle your own household? Would you buy a week's worth of groceries or a month's worth at a time? Why? Money cash flow. If we are having 1 month's grocery, more money, more cash flow will be there. More space will be required in the inventory area. So, money cash flow is affected, space inventory is affected. Say if we are having a day's inventory, week's inventory or month's inventory, and then we have to see the cash flow and the space required for inventory. Don't need so much buy when needed. So, when it is required, buy it at that time only. That is the idea behind it. So, to avoid more flow of money and the more requirement of inventory space. Perishable and obsolete goods are also there. In our house, we use perishable and obsolete, and we are very careful with obsolete and perishable goods. Why is SMED important? Line down time is costly. We need shorter changeover time. If a machine is idle, it is doing nothing, then it is a costly affair. We cannot afford to have idle machines, our funds being blocked in such a way that they are not giving any output. So, we have to put the machine in running order without wasting much of time. So, we have to work on SMED. We are losing money when the line is down, and line is down for changeover only. So, we have to reduce the changeover time. Increases profit. If we reduce the changeover time, it increases profit. It increases uptime. As we reduce the downtime, automatically the uptime of the machine will increase. What is uptime? Uptime is the machine when it is giving output is the uptime. Creates capacity. When no idle time is there, the capacity of the machine increases. Creates space in the warehouse. It also gives us a space in the warehouse because we are able to reduce the changeover time. Increases flexibility, as we have already discussed, because we are now taking least time in changeovers, we have become more flexible, our machines are more flexible, and these machines can be set to any requirement of the customers without wasting time on changeovers and setups, because we are now using SMED concept. It is a cost per unit. When there is no idle time, no efficiency is there in the system, the per unit cost will get reduced. Makes it easier for the operator to change over, because the less time is required, everything is available close to his area of operation, he will be happy to use it. It becomes easier for him to operate the machine. Easier to train new operators. As the changeover time and setup time is reduced, then it becomes easier to train the operators also. Keeps all customers happy. Here the idea behind doing all this is to keep all customers happy in the process. Why is SMED important? Improper setups can have negative effects on equipment reliability, safety and quality. SMED streamlines the changeover process, streamlines the setup process. If this is not implemented, the mistakes are possible. If the wrong setup is done, the end machine is run, it may damage the machine also. It may damage the spares of the machine also, and the machine will become unreliable and source of trouble for the technical people. So, SMED supports TPM also. Total productive maintenance can be carried out if we spare time from the changeover times, and it uses mistake proofing also, poka yoke. It also reduces injuries due to machine failures of using wrong setup. Establish standard work for all operators, and then assists with new operator training. Everything is standardized because we have reduced the time to its minimum level. We cannot afford to lose time on any non-value added activities. So, non-value activities have been eliminated from the standard operating procedure, and the now procedure is a fixed and a firm one, and operator is now trained on that standard procedure, and he is able to give us the efficient working also. Why is SMED important? Because controlling line downtime allows for better planning and supports a just-in-time strategy. If we are able to control the downtime of the machine, it means we are able to implement the just-in-time concept. Less inventory is required. just in time strategy has been implemented, it will automatically give the results like less inventory. Inventory may be in the form of raw material, semi-finished product or the finished product. Accurate scheduling is possible if our changeover or setup procedure is firm and fixed. One item flow principle is utilized in SMED. Increased flexibility, which we have already discussed. Better utilization of operator's time. When we use the operator's time in a better way, their efficiency will get improved, their morale will get improved, they will get more time to rest after fatigue. Greater profit sharing will be there, more profit, and that profit can be shared. Greater customer satisfaction, that is the main aim of SMED. Where should SMED be used? Now, quickly we discuss the areas where SMED can be used. SMED should be used on a machine or process which requires complicated or time consuming setups. On the average, 86% of a process is a waste. Here, we should look for the areas where SMED is possible. This can be seen if we record all the changeovers or the setups required in the factory. List them on one column. These are the setups required and these are the timings which we are taking presently. Then we should map the process. Each setup process should be mapped. Then areas where modifications are possible should be recorded in the fourth column. And next, we should see the areas how they are going to be modified so their setup time is reduced, operations become more easier, operations become more safer also. When this has been recorded, then this should be implemented also. And we should forecast the time required for changeover. And the actual time taken with respect to the forecast time should also be seen. Any gap so found should be studied, analyzed from the forecast time and the actual time. Wherever again some modification is required, we should implement the modification to get the results. And this process should be repeated again and again. And again, areas of modification be recorded, points be modified, and results be observed, and the changeover and setup time should be drastically reduced. SMED is supported strongly by TPM. It should be used in an area to support visual management practices. What is TPM? Total productive maintenance. When we implement total productive maintenance, we look for SMED implementation also, and we also look for visual management controls so that anything going wrong should be visible on the monitors. SMED reinforces other lean manufacturing tools also and should be used as part of an ongoing movement towards continuous improvement. It is not one time move, it is a continuously improvement technique. Rather, I should say it is a continual improvement. There is a difference between continuous improvement and continual improvement. Continuous is if you improve continuously, continual is you improve, then stabilize, then improve and stabilize. This is going to be continual improvement. This is preferred over continuous improvement. SMD gives you a platform for continual improvement. How do we use SMED? SMED as a lean tool can be used during a rapid improvement event, just do it or project. Preparation for SMD event should include gathering data to support the current state. Maybe we'll have a video recording, current recordings will be there, changeover times, frequency sheets, continuous improvement, and to-do list. There will be a list which contains to-do jobs and uptime. Maintenance schedules, safety concerns or incidents, and building a team with process knowledge, support and outside eyes. So today we have discussed SMED, single minute exchange of dies, and this is particularly a concept to reduce the changeover time to setup time. We don't want to waste our time, because during changeovers and setups the machines are sitting idle without giving any production, and if we are taking more time, customer needs will not be satisfied.
Right.
And we don't want that. We want to satisfy customers at all the times. Thank you so much, viewers.
Thank you, friends, for watching. Have a wonderful day ahead.